Okay, finding mean and RMS values. So if we look at the example, we've got a voltage with it's a peak voltage, sinusoidal with a peak voltage of 340 volts. So this could be the way that we could write the function. V equals a peak voltage of 340 and it's some sine function, sine theta. To find the mean value, if you remember when we did this, you integrate over half a cycle and then divide by that interval, pi. So 1 over pi integral 0 to pi, v d theta, where v is the voltage function, little v, with respect to theta. You'll be given this formula to find the mean value. And if you're asked to find the RMS value, you'll be given that formula too. So you're not expected to remember this. So let's use it to find the mean value. So 1 over pi, integral between 0 and pi of 340 sine theta d theta. So the 340 can come outside the integral, and we're left with this. So if now I integrate this, it's minus the cosine of theta between 0 and pi. So all I do now is put in my limits. 340 over pi, putting the top limit in, minus the cosine of pi, minus, put the bottom limit in, minus the cosine of 0. You might remember, but you can put it into your calculator, not forgetting of course that you're working in radians, that the cosine of pi is 0, so that bit's gone, and the cosine of 0 is 1. So we end up with 340 over pi minus 1, which is 1. So the answer is 340 over pi. Which, when you work it out, will give you the answer that you have. Okay, to find the RMS value, we would use this method. RMS, root mean square. It's the square root of the mean of the squared values. So we square our function v, and then we find the mean of that. We integrate over half a cycle and divide by the interval pi, same as we've just done, and then we square root, a bit like finding the standard deviation in statistics. So RMS value, the square root of the mean of the values squared. So applying this to this, our function v, remember, is 340 sine theta. So this turns out to be the integral of 340 squared sine squared theta d theta. So if I carry on and do this integral, you see if you can complete it yourself. But if we look at this, if I bring the 340 squared outside, so this is 340 over the square root of pi, effectively, integral between 0 and pi sine squared theta d theta. Now this involves the use of some trigonometric identities, and both of these you will get in the exam if you need to use them. The first one we use, cos squared theta plus sine squared theta equals 1. The second one you will need to use, cos 2 theta equals cos squared theta minus sine squared theta. We want to get sine squared theta in terms of this cos 2 theta, because the integral of cos 2 theta is a standard integral. So how we go about doing that is we look at this cos squared theta terms in here and substitute in from this expression 1 minus sine squared theta, because cos squared theta equals 1 minus sine squared theta. So I can write that cos 2 theta equals 1 minus sine squared theta minus sine squared theta, which of course gives us 1 minus 2 sine squared theta. Rearranging for sine squared theta equals 1 minus cos 2 theta over 2. So instead of writing sine squared theta in this integral, we're going to write this expression here, 1 minus cos 2 theta over 2. So the integral becomes, the RMS value becomes 340 over root pi integral between 0 and pi of 1 minus cos 2 theta over 2 d theta. Again, the 2 can come outside. Of course, this is square rooted. Mustn't forget to do that. The 2 can come outside the integral and also outside the square root to become the square root of 2. So this becomes 340 over the square root of pi times the square root of 2, integral between 0, square root of, integral between 0 and pi 1 minus cos 2 theta d theta. That's a standard integral now that we can do. Times the square root of, okay, so integral of 1 with respect to theta is theta, minus cos, cos becomes sine, so it's minus sine 2 theta over 2 between 0 and pi equals 340 over square root of pi times the square root of 2. So putting the limits in, this will be pi minus sine 2 pi, putting this in brackets, pi minus sine 2 pi over 2 minus 0 minus sine 0 over 2. Sine of 0 is 0. Sine of 2 pi, complete oscillation, is 0. So in fact we end up with 340 over root pi root 2 times the square root of, all this in fact turns out to be the square root of pi. So we have effectively a square root of pi underneath and a square root of pi at the top. So they cancel, and the whole thing turns out to be 340 over root 2 RMS value. And you might know that the RMS value is just the peak voltage divided by root 2. And this is the proof. In the exam, you will be able to use that the peak voltage is, the RMS value is peak voltage over root 2 to get a value, but then you might want to show how it works by going through something like this. It's a possible question.